So here we shall explain some properties of integrals with some examples on finding the integrals or anti-derivatives. So the property of integral is that if the various properties. So the first property is that uh, that d by dx of the integral f of x dx, that is equal to f of x. It means I can tell that integral d by dx of f of x into dx, that is equal to f of x. Or we can say that integral f dash x dx means the f dash x is suppose the uh, derivative of the function f of x. Then integral f dash x dx, that will be equal to f of x plus c. We have to add some integration constant. C is called the constant of integration or the arbitrary constant. And the second property is that if suppose d by dx of integral f of x dx, that is equals to also the derivative of the function integral g of x dx, then we can say that d by dx of integral f of x dx minus integral g of x dx, that is equal to 0, which means that integral f of x dx minus integral g of x dx, that is equal to some arbitrary constant. C is some constant. So therefore we can tell that f of x dx integral, that is equal to integral g of x dx plus c. Then the third property, the third property is that integral f of x plus g of x dx, so that will be integral f of x dx plus integral g of x dx. Then the fourth property is that if there is any if there is any constant which is multiplied with the function f of x, and we have to take the integral of that, integral k f of x dx, so that would be equal to k times integral f of x dx. So these two properties, the third property and the fourth property, can be generalized. The fourth and the third property can be generalized as, so one generalized rule we can tell, one generalized rule or property, that is that if we have some functions f1 f2, if f1 f2 f3 till fn are some finite number of real valued functions, finite number of real valued functions, and k1 k2 k3 till kn are some real numbers, are some real numbers which are some constants. Then we can say that the integral of k1 into f1x plus k2 into f2x, f2 of x plus dot 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 plus kn into fn of x. That will be equal to, so constant will come outside of the integration, and the sum we can add them separately, and we can integrate them separately, then we can add, and this into dx, sorry. So this will be equal to k1 into the integral f1 of x dx, and plus it will be k2 into integral f2 of x dx, plus this will be k3 into integral fn of x dx, plus this will be equal to plus sorry, this will be 3. So this will be kn integral fn of x dx. So then we can explain it by using some examples. Suppose if it is asked to integrate the function integral x power 3 by 2 plus 2 e power x minus 1 by x dx. So if we have to integrate it, then we will get integral x power 3 by 2 dx plus 2 into integral e power x dx minus it will be integral dx by x. So this will be equal to x power 3 by 2 plus 1 by 3 by 2 plus 1. Since we know that since integral x power n dx is equal to x power n plus 1 by n plus 1, and so plus it will be 2 into integral e power x dx is e power x only, and integral 1 by x dx is equal to log mod x. So then we can write it as, this will be 2 into e power x minus log mod x plus arbitrary constant c. So therefore the final answer is, this is 5 by 2. So this is 2 by 5 into x power 5 by 2, x power 5 by 2 plus 2 e power x minus log mod x plus c. So and then we can also see another example, that is, suppose we have to integrate suppose 3 cosec x into cosec x plus 5 cot x into dx. So then we can write it as integral 3 cosec square x plus integral 3 5 is a 15, sorry. First we can write this as, this will be 3 cosec square x plus 15 cosec x cot x into dx. So now here we have to use the rule that since we know that integral cosec square x dx, that is equal to minus cot x, and the integral cosec x cot x, that is equal to minus cosec x, plus c is there obviously. Arbitrary constant should be added if there is indefinite integral. So this will be integral 3 cosec square x dx, then plus integral 15 cosec x cot x dx. So these constant will come outside of the integral. So this will be 3 into integral cosec square x dx, plus it will be 15 into integral cosec x cot x dx. This will be equal to 3 cosec square x. So integral cosec square x is minus cot x. Then plus this will be 15 into, this is minus cosec x plus c. So this will be equal to minus 3 cot x minus 15 cosec x plus c. So this is the answer. So these are some of the examples which are using the properties of the indefinite integrals. Thank you.